Hello, in this video we are explaining about our cloud workflow executor. We have already created a workflow and tried to execute this workflow in EC2 cloud. And for time's sake, I have already executed this workflow. As you see, this workflow has three main branches. And I have already formulated the table here. So on branch 1 you have T1, T2, T5, T8 and a T-end, right? So that is T1, T2, T5, T8 and T-end. And in the second branch you have T1, T3, T6, T9, T-end. Okay, so that is right here. And then on the third branch you have these tasks. But then in algorithm 1 we identify all the starting tasks, right? If you see, the starting tasks are those tasks that contain input data connected to it. So T1 has an input data connected, which is the data product 1, and T2 has a data product 2, and T4 has a data product 4, right? So these are three tasks that are part of the starting tasks. So and hence you would have all these starting tasks put into a separate list in our algorithm, and then you can see whenever you add a particular task to a branch, um, we don't add the same task again to a different branch, and hence you can remove T1 and T-end from branch 1 and branch 3. So let me remove these here. Okay, and then each branch here is assigned to each virtual machine in the cloud, right? So branch 1 is assigned to virtual machine 1 and so on, right? So I have already executed this workflow, and you can see that all these individual branches were executed in parallel and it produced a result. Okay, so the goal of algorithm 1 is then to create clusters, right? It creates a cluster for each machine. Each machine has a cluster, so we can think of it like this. Each machine is a cluster of tasks, right? So um, again, the cluster can also be looked up as a branch, in our case branch of the workflow. Okay. Okay, so the algorithm 1, the goal is to formulate a table like this, right? So that we can use this table in order to execute the workflow in type A workflow executor, right? So let's look at our algorithm 2, what it does. As I said, algorithm 2 will first try to execute all the starting tasks, right? The starting tasks in our case is T1. Let's again go and look back at our workflow diagram. You have T1, T2 and a T4. Those are the starting tasks that contain at least one input data associated with it, right? Or you can also look at that as these tasks should not have any intermediate data as input to the task, right? So all these tasks T1, T2 and T4 doesn't contain any intermediate data as input to those tasks. Okay, in algorithm 2, first we would execute a branch 2, let's say, and T1 would be executed, so that is right here. But once T1 is executed, the status is finished, only then T2, T3 and T4 can be executed, except that here T2 and T4 are scheduled to run on a different virtual machine, right? So T1 status finish, let's say after completing T1, then you continue to execute T3, T6, T9 and T-end, um, right, on branch 2. But then keep in mind, T-end has the input data that is coming from different branches, right? So T-end cannot execute until all the data becomes available, right? So and hence we need to wait, when it comes to t-end, we need to wait until all the data becomes available. Okay, so that's the idea of branch 2. And then you can see that once T1 finish, the status is finished, then the data, output data T1.01, right, it will be moved to VM1 and VM3. So as you see here in our diagram, you know that T2 is assigned on VM2, T4 is assigned on VM3. So the output got to be moved to those machines. Whereas for T3, the output does not need to be moved because it is in the same machine, right? Okay, at this stage then you can continue branch 1, which is right here, T2, T5, T8, execution on VM1, and after T8 finishes, then the output is sent to VM2, right? So if you see again from our diagram here, the output of T8 need to be sent to the machine that hosts T-end, which in this case is VM1, right? So the same thing with branch 3, the output of T10 would be sent to machine 1. Okay, so that's exactly what we have captured here. And these are in parallel. We will execute branch 1 and branch 3. And once this execution is completed, then you will continue execution of Tn because all the input data are available, right? So at this stage, all the input data are available, so you can execute Tn. So if you look at the parallelization right here, although this workflow is all executed in parallel, because of that waiting time that you have, because of the data dependency, so you can say that from here, if you put a line, straight line right here, and straight line right here, right? These are only tasks that are running in parallel. Okay, why? Because there are data dependencies. Whenever there is a data dependency, and which means that in our case the data is not ready yet, so then those tasks need to wait until the data is ready. Okay, so that's in short our type A algorithm and the CTA algorithm explained in this video. Thank you for watching this video.